So the next topic is that is linear differential equation. If P of x and Q of x are functions of variable x, then the differential equation dy over dx plus px of y is equal to q of x is called a linear differential equation. For example, dy by dx plus xy is equal to cos x, or we can say another equation dy over dx minus y over x is equal to e raised to power x. So here we can see that this is a form of dy by dx p of x y is equal to q of x. Dy by dx minus 1 by x is p of x is equal to qx. So this is the form of linear differential equation. Now method to solve. Linear differential equation. How can we solve this linear differential equation, and what is the solution after solving it? We get let dy over dx plus px of y is equal to q of x be given linear differential equation. If we multiply both sides by e raised to power integration of px dx, we get dy by dx into e raised to power integration of px plus px as it is e raised to power integration px into y is equal to q of x e raised to power integration p of x dx. So if we see that if we take y as first function and e raised to power integration of px dx second function, then we can see derivative of first function, second function as it is, first function as it is, derivative of second that is e raised to power same, and derivative of integration of px dx is px. So this can be converted in the form that is derivative of y into e raised to power px dx is equal to qx e raised to power px dx. So on integration we get y into e raised to power px dx is equal to qx whole integration of qx e raised to power px dx of dx. So this is a required solution. Also when we get a linear equation, linear differential equation. So what is meant by integrating factor? When we multiply differential equation by a factor, to make it easily integrable, then this factor is called integrating factor. In the above equation, e raised to power integration of p dx is called integrating factor of linear differential equation. Now we will solve some problem which is based on linear differential. Now we are going to solve problem based on linear differential equation, that is solve dy over dx plus y over x is equal to x square. Now the solution is, as we have dy by dx plus y over x is equal to x square. Compare with dy by dx plus py, that is p of xy, is equal to q of x. So here p of x is 1 by x and q of x is x square. Now as we know, the general solution of a linear differential equation is given as that is y into e raised to power px dx, that is 1 by x dx, is equal to integration of q, that is x square, into e raised to power 1 by x dx integration, then whole integration of this factor. We get y into e raised to power integration of 1 by x dx is log x is equal to integration x square into e raised to power log x whole integration. So we get, as e and log are complementary to each other, so we get e raised to power log is cancelled out and we get y into x is equal to integration of x square into x dx. So in the left hand side we get xy is equal to integration of x cube dx. Powers will be added as base is same. So we get xy is equal to x4 over 4 plus c by using power rule in the integration, that is x raised to power n dx is equal to x raised to power n plus 1 over n plus 1. So which is the required solution of linear differential equation. Now the next problem is, that is problem number 2, solve dy by dx plus y into secant x is equal to tan x. So here p is equal to secant x and q is equal to tan x, and given equation is the form dy by dx pxy is equal to q. Therefore its solution is y into e raised to power p dx, that is secant x dx, is equal to integration of q into e raised to power p dx whole integration over the variable x. So we get y into integration of secant x is log of secant x plus tan x is equal to tan x into e raised to power log of secant x plus tan x into dx. So as e and log are complementary functions, so we get y into log of secant x plus tan x is equal to integration of tan x into same e and log cancel out secant x plus tan x over the variable x. So we get, log is cancel out. So y into secant x. So we get y into secant x plus tan x is equal to tan x secant x dx plus tan square x dx. So we get y into secant x plus tan x is equal to integration of tan x secant x is secant x. So as we know that tan square is secant square x minus 1. From the identity secant square x minus tan square x is equal to 1. So we get y into secant x plus tan x is equal to secant x. Integration of secant square x is tan x. Integration of minus 1 is x plus c. That is our required answer, which contains the constant c. So it is a general solution of linear differential equation. Next problem is solve dy by dx plus y by x is equal to log x. So here if we see p of x is equal to 1 by x and q of x is equal to log x. Therefore its solution is y into e raised to power p dx, that is 1 by x dx, is equal to integration of q into e raised to power 1 by x dx whole power dx. So we get y into e raised to power log x as the integration of 1 by x is dx and log x into e raised to power log x dx. So we get as log and e are complementary functions, so y into x is equal to integration of log x into x dx. So we get by using integration by part on the right hand side. So we get first function log as it is, differentiation of integration of second function minus differentiation of first function, integration of second function all over the integration over the variable x of whole function. So y into x is equal to x square over 2 into log x minus, that is x by 2 dx. So we get y into x is equal to x square over 2 log x minus x square over 2 into 2 is 4 plus c. So which is the required solution of linear differential equation in general solution form.